In the last video, we talked about the different properties of lines, things like slopes, intercepts. In this video, we're going to look at the different equations of lines. As far as it goes, there are 3 different equations of a line. We use 2 of them more than a third, but I just want to show them and see how we can kind of use them to graph lines and solve different types of problems out. So first off, we have what's called standard form of the line, which is ax plus by equals c. And essentially the idea is, if I have something like 2x plus 4y equals 8, we want to recognize that this is the equation of a line. The problem is, if I actually want to graph it or find the slope or anything, that doesn't really help me beyond maybe picking x and y values and plotting points and then getting an idea of what's going on. So while that's called the standard form, the most common form, it's actually the one that's probably one of the least useful forms. The one that we actually use more often is called the slope-intercept form. Which is y equals mx plus b. And as far as the letters go, as we said before, m is just the slope. Right here, b is the intercept, and in particular, it's the y-intercept. And essentially the idea is, if I have something like y equals 3x plus 2, then I know immediately I have a line with a slope of 3 and a y-intercept of 2. So if I wanted to graph it, I could just say, let's see, the y-intercept is 2, so that's the point 0, 2. Slope of 3 means up 3 over 1, up 3 over 1. And I quickly get an idea of what my line looks like. So this is kind of the most common way we generally write our lines, because it allows us to quickly get all the information we want to work with the line. One thing I would point out though, as far as it goes, up to this point when we've been solving problems, generally we're solving an equation for x. X is our variable, we solve for x, isolate x, get x by itself. Once we start talking about lines and some of the other things we're going to look at, now I have 2 variables, x and a y. And generally now, after spending all that time solving for x, now we solve for y. So in this case, if I solve for y, first I subtract the 2x, so I get 4y equals negative 2x plus 8. Then I divide the 4. Y equals negative 2/4, which is negative 1/2 x, plus 8 over 4, which is 2. And we see now why we actually do that, because now that takes my line in standard form and just solving for y puts it in slope-intercept form. And now I immediately know there's my slope, there's my intercept, I can graph the line. So essentially from here on out for the rest of the semester, when in doubt when solving a problem, if you have a bunch of variables, just solve for y. So, we have those 2 forms of a line. The last one, which is actually my personal favorite, but some people don't like it as much, is the point-slope form. And the way it works is, this equation is y minus y1 equals m times x minus x1. And essentially, that m is still my slope, but now I have an x1 and a y1, which is just a point. The point x1, y1. When we math people name things, they're very creative. This is slope-intercept because it has a slope and an intercept. This is point-slope because it has a point and a slope. But, well, essentially now the idea is, if I have something like y minus 2 equals 3 times x plus 4, if I wanted to graph that line, well, according to that 3 is my slope, and these 2 numbers represent a point. Just keep in mind, in this equation, the negative is part of the equation. So for this, my x value is not 4, it's negative 4. My y value is not negative 2, it's positive 2. Just remember to switch the signs for all the numbers because the negatives are part of the equation. Which means then, I have a point, I have a slope, I can graph the line. My point is -4, 2. My slope is 3, which is positive, up 3 over 1. And there we go, there's the graph of my line. Oh, and I'll also point out, as we've graphed a few lines here, all things being equal, when I want to graph a line, could I pull out some graph paper and a ruler and sketch everything and have everything absolutely perfect? Yes, but for the purposes of this, I care more about the understanding of a line, which means I care about understanding. There's a slope, there's a point, the slope is positive, so I find the point, slope goes up, slope of 3 isn't very steep, and I'm good to go. If there's any other information I need from my graph, I'll find it algebraically. This is more just a guide to give me a visual clue on what's going on. But suppose we have this. Y plus 2 equals 2 times x minus 1. So I want to graph that line. Let's see. I have a slope of 2, and I have an intercept of, switch the signs. I'm saying not an intercept, a point. Switch the signs. So x is 1, y is -2. So we get the point 1, -2. I have a slope of 2, which makes my line go up like that. One thing we can do to kind of make sure we know what's going on, we're doing things correctly, that line is in point-slope form. Convert it to slope-intercept form, and then see what we get. And in this case, like I said earlier, easiest way to do this, always just solve for y, for all of your equations. So here, distribute the 2 in. So I'll get y plus 2 equals 2x minus 2. Subtract the 2, y equals 2x minus 2 minus 2 is minus 4. And now we know right here, this is the point 1, -2. We did that up there. And if we look at this line, this would be a line with a slope of 2, same as that line. It would have an intercept of -4, which makes sense. This was 1, -2, so this being 0, -4 makes a whole lot of sense. And you can just use that as a guide to make sure you're actually doing these things correct. Jump back and forth between the different equations of a line. Ultimately, in problem solving, this is the most common, the slope-intercept. And to solve for it, you always do the exact same thing. Solve for y. Solve for y, isolate y, get y by itself, whatever. Occasionally, we do go backwards. So for the sake of argument, suppose we have y equals 1/2 x plus 2. Say I want to put that in standard form. Well then let's see. In standard form, the x and the y are on one side of the equation and the constant is on the other. So, subtract the 1/2 x. I'll get -1/2 x plus y equals 2. Now I have the x and the y on one side of the equation, the constant on the other. But the problem is, as far as form goes, for standard form, I generally want to try to make these integers just to make it neater. So here, multiply everything by 2 to get rid of the 1/2. You'll get -x plus 2y equals 4. Now I have all integers. But again, for standard form practices, we generally don't like our leading coefficient negative. I like my leading coefficient positive. So I'm also going to multiply everything by -1. Then you'll get x minus 2y equals -4. Now that's in standard form. So we start with slope-intercept, and we can go backwards to standard form. All things being equal, like I said, generally speaking, we're actually not going to work in this direction. We'll start with something like this, and then get to slope-intercept. But you should understand your algebra well enough to be able to go back and forth from any form to any other form. There's a few more properties and problems we can solve with these lines and these equations, but I'm going to put it on another video so this one doesn't become too long.